In this video, I will fit silver sulfide using KherveFitting version 1.71. This example can be found in the example menu in Ag2S menu. So you can open it here. It's already been fitted. If you open that, we will try to fit it ourselves now. So it is made of, if I open the sample manager, obviously one row, silver 3D, carbon 1s, oxygen 1s, sulfur 2p on survey. So when I have a new sample, I always look first at the survey to see what I have on my surface. I tend to first look quickly at the manual identification here and use that to go through. So the usual suspects are carbon. So looking at it, we have carbon. We should have oxygen, but not much. We expected silver, so it's all there. And then we have, this is usually the location of the auger, so that will be the auger of silver. And we have those two picks, and we have then another two pick here. So two picks usually means 2P2S, and then you can go down. The 2P2S start at aluminium, so aluminium at 73, silicon 99, phosphor 133, and sulfur 166. So this is close. If you can read this value here, this is close to 166. If I put it, you can see straight that it comes to sulfur 2p and sulfur 2s. And then we can go up and up and up in binding energy, and this is around 934, so we go 778, and 933 comes copper, so this is copper, but we don't have to pick, so we have a doublet. We don't have to pick because we have copper 2p 2s, but 2p is too small to show the copper 2s. Okay, so this is what I will first do, and then usually I also do an automatic identification to run to see what is the concentration of my elements, and maybe I'll modify it quickly. So we do that here, so we get now something quite nice. Nothing seems to have been missed. Silver 3s is there, silver 3p, CKLL, he hasn't shown the silver, but he found the copper. And even when we zoom now, this is also quite nicely done, but you have to know that this is all done with the Tougaard background. So now Shirley, and those sensitivity factor has been used on measured with Shirley. So it's not really a true indication of the measure, but it's a good enough indication. If you want to change this, you can simply go into the measure area here, or going back again using this edit area. So that's the same one. So I'm just going to open that, and you can simply switch between regions like this. So the first one is always 10 to 90, so you can find it in your regions, and now it's going to go through each element. So this is the silver. The silver, you can see it's been done here. So now if I try to move it, you see it's just coming to the center. It's not moving. But so I can't change the width. I want to go up to here. And again, if I just go there, you see it's not helping me. But you can just start from there and just move slowly here. And then the same here. It's not going to work. You can see it's not working. So I'm going to go from here and then just go down there. Okay, so this should be a good level for Shirley. So I'm going to select Shirley here, or Smart. But let's just go for Shirley this time. And I make sure that Silver 3D is selected. And unfortunately, it will always zoom out. So you have to look again. But now this seems to be quite good. Okay, and we can do the same maybe with sulfur, because this is what we are interested in. The rest seems okay, but let's continue. So silver, carbon, and now sulfur. So we go again. You see it's not moving, so let's just go somewhere here and maybe somewhere around there. Surely, yes. Ah, sorry, it's added selenium. That's one of the things you have to make sure that is on the right number. So let's just remove selenium. Let's go back to our carbon, and let's choose again the carbon in, sorry, sulfur. So sulfur core level list. I'm just going to keep this here, and now choose the right one. Somewhere there. I'm looking at this. This is selenium. I'm going to press for sulfur, create my background, and now this has been done almost correctly. So this is now done. We have something quite nice. We can do the same with carbon, but for now I want an indication of the ratio between sulfur to silver. So this has not been yet updated. Let's just go to oxygen. Let's go back. And now you should have something. You can see a ratio of 1 to 2, so Ag2S. And that's quite good. It matched quite well. This is done on a CMOK alpha, and yeah, this is usually very good. Okay, so now we are going to go to first maybe carbon and try to fit this quickly. So for that, I'll tend to go, yeah, somewhere around there. I may go down again into the background, choose something maybe around there. Yep, that sounds good. And maybe I will simply go into my library again. This is one thing I like to do, and I tend to choose now the SGL because the void or SGL is so similar, and the SGL is simpler to explain to first time users. So SGL, 4 picks, and now I have them all, and let's see if I can fit this quickly, and they've all been created with some kind of constraint, so they're all constrained to the first pick and constrained in width as well, as you can see, and in LG ratio. So this is what we tend to use. The rule of thumb is they should all have the same width. And if not, there must be a good reason. Like if it's a stronger bone, like graphite, or then you would tend to have different widths, but this is not the case. So now we have our CC, and we can find that this is 284.8. This was binding energy corrected before, so 0.28. You can change that using, this is how you do it. So you put 0 and you click on the plot, and to get this back, you can click on this binding energy correction. That's how you would do it. And by default, and you can change that in the preference, but by default is looking at CC 284.8. Okay, so once that's done, we can go now to something like the Silver 3D. So the Silver 3D looks simple and easy to fit, but it is actually, I find, quite difficult. And often I use a different background. But let's show you what we do. So background, we use a smart, create regions, and it looks all good, more or less, because we have here something that is around there. So let me just go quickly. Maybe here it looks all good. When we go down into the noise, that's kind of what we get. Okay, so let me zoom out now, and let me pick fit this, and I will use my SGL and fit that. And what you can see is the standard with silver is there will be it will not be able to fit in this side here. And again, much worse if you're just going close to the noise. So this is common. You can't really fit it here. It may be that it's got another pick, but I find that this is typical of silver. So what I tend to do is I would try to use a Tougaard background instead, and that seems to usually work well. So I will show you with the Tougaard. So now all you do is, for example, you use U2 Tougaard, so that will be that. And if you just move it, now it's a U2 Tougaard. And for U2, I will try to go, yeah, to go around there, and that seems to be way better. So yeah, fitting quite nicely here. Maybe let me go down here, and if I fit this now, this is, yeah, quite nice, just not matching quite well here. And just because not many people use U4 Tougaard, it seems to be quite difficult to use, but on KherveFitting it is quite simple. So let me show you how I would do it if I use a U4 Tougaard. So you go into this U4, and now you have this button open. So if you go to U2, this is just disable. So U4 Tougaard, you get this pick fitting thing. Okay, let me put that away. So what does it do? This is actually a fitting window for Tougaard. So it will try to fit a, the Tougaard between those regions. So it won't. It's different to Raman, where you will do exclusion zone. This actually is the fitting zone. So let's put it movable. And what you want for Tougaard is that it fits at the end. At best case, I would like this to be further around 390, but this is what we have at the moment, so I will make it so that it fits exactly there. And usually I like to have my C parameters to be between, let's say, 400 to 500. So I will put that to 400 and put that to 500, and now I will fit it. And that's it. It's already done, so it's not very difficult. You can also use control down, and you can then see what you have. So here you have a standard way where the background is increasing by the middle of the pick, and then you have a second increase in here. So this will be changed by using especially the C parameter. Okay, and the B parameter is the one that was fitting using this range. So if I now was changing from here and fitting it, now I will try to fit it right there, and it had to go to something much sharper. Okay, so I simply prefer this one here, because I know that the Tougaard should really be equal to the background at much higher binding energy. So now what I can do is I can copy those parameters that I found into here. So they are not shown right now, but if I just click copy, they are copied here. Okay, and now what I will do is, yeah, they are already fitted in here, so I can close that because I created that region. I didn't need to create the regions. Let me just remove. That's the one here. I created, and now you can see, yeah, you can see it's there, and it should really fit exactly where we said, so somewhere around there. Okay, so this is what I would tend to use for silver. Now you zoom out, and you can see that this is quite nice, and we fit it, and we have just two picks. Okay, so this will have, if you looked at the Mark Bissinger, let me just open that here. Okay, so now we can put it in S, and we can now go to the NIST, the offline NIST, and maybe go to the, sorry, not S, silver. Yeah, and choose the 3D 5/2. Then you have AGO, and if we look at Ag2S right here, so it's got SC, but S is shown here, and we can do sulfide maybe to even differentiate between them. That's it. This is all the Ag2S, and you can see it's not many, and they're all around 368.2. A plot will not change much, but you can see that's where they are. So you can also go to again, Mark Bissinger website, look at the AG and go down, and you will get different type of pick fitting. So this is for the AGO, and for the AGO you should really take the OG, but in this case it's just Ag2S, which is simpler, and this is 368.1. So it is quite similar. We have 0.2 EV difference, and I think this is good enough. Now we can go into our sulfur and pick fit the same way. So because we pick fitted with the Tougaard on the silver 3D, I would also fit the sulfur with the Tougaard. So you go now to background, you can go back to this Tougaard thing, and the same way, so we go to movable, to move those ones, you have to tick the movable, and this is, unfortunately, I don't know why you went to 154, but it's not on the window. So let's just get it on the window, 160. Okay, so same thing, we will just move it somewhere there. We will also choose it between 400 and 500 for the C, and then fit it. Okay, so now we have something that looks good. We can maybe go down and see how, yeah, that sounds good. We could also change the starting range, so you see it when it started there. Maybe we will start somewhere around here, so let's fit again, and maybe further down. Yeah, and further down, one more. That's it, something like that. So now this is good. 500 it's good. This is at the maximum 1,200. I think this should be it should stay around 1,200. So we can copy this into here, and yeah, that's it. That's copied. So we can close that, and we can create our U4. Looks like that. Now SGL again. It's a doublet, so we add the pick and we fit it, and you can then see that it is not fitting, and also here it's not quite. So maybe let's go back to the background and zoom down. Again, control down also, and we can see, yeah, what we've done, it wasn't quite correct here. So let's just make it so that it fits exactly. And if it doesn't, then we will put one. Maybe that will do something. And we can also move that using our cursor. So let's just go one at a time, like that, until you find something good. Come on. Yeah, I think. Okay. Somewhere around there. And now obviously this is too high. Huh? We found on silver, we found that this was 53. So they will again tend to have similar pick shape. So maybe we'll go around 50% and fit again. Okay. Then now zoom out. So what we can see is we can't fit it with one. There are actually two sulfur. It may be that we have a silver sulfide and a sulfur at the top of the silver, and so we add two more, and again we go through the rule of thumb of making the same width for the C to the A. So this is the constraint here, and we type C, sorry, not C, type A, and now we have those two should have the same width on the same shape. So let's go with it, and now it's fitting quite well, and this is our SAG. Okay, this is the same thing, SAG, and this is our second SAG, I believe. Slightly higher at 162. -2. Okay, so that's our two doublets, and in here this was our AGS. Okay, and now we can just finish with the oxygen. So the oxygen, I would recommend to go with the area. We don't really need to create a pick of this. And then for that, we will just create something like that, looking if it's oxygen, go into the, yeah, U2 Tougaard, because that's what we started creating. And now we have this 5C2 points, it's usually OC. Okay, so once this is done, we can export that into the results grid. This was already done before, but let's go into this export and we select tick, not the survey because this is done at different pass energy, so we should not select that. And we export that, and what you get is something with the carbon 1s, fine, and something with sulfur and something with silver. So all you have to know is sometimes the 1/2 is still ticked, so you can untick this, making sure that the 1/2 is not ticked is the same as that. So you can see that this is 16.7 is almost the same number. So now you can look at all of them. So let's just untick the carbon 1s because it's a bit easier for us to understand our ratio. But what we get here is 67. And so that means it's like because we have three atoms, two silver and one S, and that means yeah 3. So that's exactly what you expect. So 33 to 66.67 or 67 here. So it's a very good affirmation that we have silver 2S in here.